Alright everybody, I'm going to walk you through this demonstration video. The video itself doesn't have sound, so I want to talk you through what's going on. It's showing you how a front forms between two different air masses. Now, air masses depends on where they form, but they have different temperatures, air pressures, different humidity, meaning different amounts of moisture. Warm air masses tend to hold more moisture. Think of it as like a sponge with more holes, able to hold water, and cold air can't hold as much. So because they're different temperatures, they have different densities. So this brings us back to week 6, if you remember the density tower with the different liquids poured into the cylinder. Very similar, the same idea. They don't mix because they have different densities. So we're going to watch the demonstration. He's showing you, or this person is showing you right now, that these two sides of the water tank with a glass divider in the middle are different temperatures. This one's cooler, this one's warmer. They're not very different. I believe they are using degrees Fahrenheit, so I think they're about 3 degrees apart. Now when the divider moves, I want you to watch this edge right here. Very slowly, we start to see the cold water flowing across. Now, it does kind of look like the warm is flowing across the top, but what's actually happening right here as the colder water, because it's more dense, drives across the bottom of the tank, it's only going to hang out at the bottom. It's very stubborn. It's actually pushing this warm water up above it. So the warm is going to track its way over to the right, while our blue forces itself over to the left. So the power and the force is behind the more dense cold air. So along where my mouse is, you're going to see things like heavy rain, sometimes thunderstorms, sometimes even severe thunderstorms, hail, and tornadoes. Now notice, we're going to pause here for another second. Now that the cold air, or cold water, has driven all the way across the tank, it's now basically taking up the bottom of the tank. Now in the atmosphere, it doesn't really run out of places to go because our Earth is round and air is going to keep moving across. But in this tank, what you're going to notice is basically once this cold water hits the left wall, it's going to kind of bounce back. But the idea here is important. Warm air is going to be less dense than cold air. Warm air will always get pushed up over cold air. So now what you're seeing is kind of that cold bouncing back. Once things level out, and it kind of has that return, you're going to notice that the cold water is going to stay at the bottom. So this would be a really good demonstration of a cold front. I'm going to do one more time. So right here, this line between the red and the blue would be the front, and the red water is the warm air mass, the blue water is the cold air mass, and the front is the boundary between. They don't mix because they have different densities. And where we have a front, the more different these temperatures and their air masses are, the more difference in density, the more severe the weather along the front. So this is a pretty good example of what a cold front can look like. I have another version of a demonstration for you briefly. In this one, same idea. The warm water in this one is a little bit warmer, and this time this person's tank is set up so the cold is on the left and the warm, or kind of hot water, is on the right. Because these two are more different, this is colder and this is even warmer than the last demonstration, this one goes a lot faster. So this was in real time. Watch this cold front. Now the cold front's moving left to right across the screen. This one's like a wedge. It drives that warm water right over the top. Watch how quickly that happens. So if you're standing here, you're seeing all kinds of thunderstorms moving across the land right here, pushing warm air up. When that warm, moist air rises, it lets go of some of its energy and releases in the form of a storm and heavy rain. So her tank's a little bit wider, but same idea. The cold, denser air is on the bottom, the warm, less dense air is on the top.